It's always pleasant to hear about some groundbreaking discovery from our dear scientists and researchers, but when the discovery takes another turn, especially when it's something that has the potential to cause a worldwide blackout, fear prevails. Join us in this video as we discuss CERN's discomforting announcement regarding the activation of the famous Large Hadron Collider and what potential threats this new development brings to our world. Understanding our world is something we can never get tired of. From NASA to Tesla and hundreds of other organizations, there's a never-ending hunger for discovering the unknown. And so, while organizations like NASA and Tesla focus on space and interstellar exploration, companies like CERN try to learn more about the Earth itself and unlock any of its hidden potential. In case you're not familiar with the name, CERN is the European Organization for Nuclear Research. It is one of the largest and most respected centers for scientific research worldwide. At CERN, scientists, physicists, and engineers try to unravel the mysteries of our universe and answer the most mind-bending questions in science. They investigate other dimensions, dark matter, and other unproven theories using large and complex scientific instruments you've never seen before. CERN is known for its groundbreaking discoveries like neutral currents, Higgs boson, and the God particle. However, as you know, the thirst for scientific knowledge never ends. And so, despite all these, CERN still presses to uncover more mysteries in the fabric of the universe. One of the things CERN hopes to discover is magnetic monopoles. Magnetic monopoles are particles that have either a north or south pole only. Usually, any magnetic particle should have both north and south poles, but monopoles have only one. Although these particles exist in theory, scientists have never found them despite searching for the past century. This search is one of the things that led to the birth of colliders. Colliders are supposed to cause a collision of particles so that scientists can then study the products of the resultant explosions. Although scientists expected monopoles to be born from their colliders, none has been found so far. The drive to discover new types of particles and perhaps monopoles drove them to create the Giant Particle Collider, the LHC. The LHC is the Large Hadron Collider, a superparticle accelerator made to propel subatomic particles to extreme energy levels in a controlled manner so that scientists can study their interactions as they move and collide. In simple terms, particle colliders smash atoms to pieces, allowing scientists to study the results. Before this smashing can occur, the particle must first be accelerated or pushed using electricity. The Hadron Collider can speed up these particles so fast that they move at almost the speed of light. The LHC uses electromagnets to function. The electromagnets use a current of over 11,000 amperes to generate the magnetic field. Plus, a superconducting coil inside the LHC ensures no electrical energy gets lost during current transmission. The LHC is located about 328 feet below ground. It measures approximately 3.8 meters in width, and its walls are lined with very sturdy concrete. Its location was also carefully chosen to minimize the background radiation the Earth's crust provides. Thanks to all these, the LHC can produce some potent magnetic fields about 1,000 times stronger than the Earth's magnetic field. The LHC features thousands of lattice magnets, which are used to adjust the trajectory of the particles. In short, the LHC is a 27-kilometer ring of superconducting magnets. Some special magnets, called dipole magnets, are also used to bend the particle paths. The LHC has about 1,300 of these dipoles. Each of them weighs 35 tons and measures 15 meters in length. Given the size and length of these magnets alone, you can imagine how cumbersome the LHC is and how much time, money, and resources it took to build it. Currently, the LHC operates at such tremendous energy that trillions of particles can circle across the collider 11,000 times per second. Such terrific speed makes this collider the #1 in the world. The particles in the LHC are constantly accelerated via the use of accelerators. As one beam of protons is blasted in one direction, another is sent in the opposite to collide with the first. The LHC is unarguably the world's greatest and most advanced particle collider. And so you can imagine the joy of the science community when it finally became operational after 3 years of waiting. This invention was born from the European Union's desire to increase our understanding of the universe, so the building process was done meticulously, lasting several years. And from its initial launch, the Large Hadron Collider proved a valuable tool in scientific discovery. Building such a complex machine was no small feat. You see, through the high-energy collisions within the LHC, scientists learn more about the intricate structure of the subatomic world. The collisions that happen within particle colliders are not strange to science. They happen every day in the atmosphere around us. Every time these collisions occur, a complex spray of other smaller particles is released as products. However, the products from these natural collisions are pretty elusive and decay rapidly. Some decay in less than a second, making it impossible for scientists to study them directly in their natural environment. The only way to explore them is in the vast tunnel of the particle collider. Construction of this magnificent structure took about 5 years, starting in 1983 and ending in 1988. The cost of the construction was about 7.5 billion euros. This cost earned it the #1 spot among the most expensive scientific instruments ever built. Because particles collide about 600 million times per second in the Large Hadron Collider, the data generated by the LHC and its simulations every year is estimated to be about 15 petabytes. A petabyte is equivalent to 1,000 terabytes. You can imagine how tough it must be for CERN scientists to review that amount of data every year. No wonder the LHC is a collaborative project incorporating scientists from all over the world, not just from Switzerland. The LHC became operational on September 10, 2008. However, due to a magnet quench incident, its initial testing period got delayed for over a year. The incident led to the damage of over 50 superconducting magnets and their surrounding components. And so it wasn't until 2010 that the LHC finally got its opportunity to shine. From 2010 till 2013, scientists could witness a never-before-seen spectacle as protons and lead nuclei were fired at mind-blowing energies into head-on collisions. This event was a truly revolutionary moment for science. But then it wasn't enough. However, as all sophisticated as the LHC was, some things still needed to be corrected. Because of this, the team at CERN felt this super collider required a makeover, and so it was shut down in 2013, remade and launched again in 2015. The 2-year upgrade was termed Long Shutdown 1-inch or LS1. During that time, CERN enhanced the LHC's accelerators and detectors and replaced some of its magnetic systems. They did all these so that the device could function at full power. Thus, in 2015, it was reactivated. However, in 2018, the Large Hadron Collider was shut down again to receive some further upgrades. This time around, CERN wanted to improve the luminosity of the LHC. The luminosity of a collider is the ratio between the interaction cross-section and the event rate. Simply put, it's the number of collisions that happen in a given time. More luminosity would make for more data that scientists could use, and so CERN upgraded the LHC to a high-beam luminosity device. This time, more than ever, CERN was trying to get to the root of monopoles and dark matter. If you're a sci-fi fan, you will have heard about the dark matter before. Dark matter is material believed to exist in space and take several forms. They do not absorb, reflect, or emit light, hence their name. More so, they can't be seen directly and they can't be detected electromagnetically. Scientists believe these types of matter came into existence soon after the Big Bang. Dark matter was another puzzle CERN wanted to crack with the Large Hadron Collider. You would think that after undergoing 3 years of upgrades for 2 good times, the LHC would return to give a scientific breakthrough. But it didn't. Instead, it caused something unexpected, something more of a catastrophe than a breakthrough. You see, soon after its launch and initiation, when scientists at CERN turned up the Large Hadron Collider with the new maximum energy beam, they detected something unexpected in our planet. Shocking data from CERN. When the LHC reopened in April 2022 with its new maximum beam energy, rather than detecting dark matter or monopoles, scientists soon detected a crack in the Earth's magnetic field. In other words, CERN cracked Earth's magnetic field in its pursuit of dark matter and monopoles. You see, the Earth's magnetic field does not crack. The only thing that seems like a crack is an opposition existing between the magnetic fields pointing south and those pointing north. These two forces partially cancelled out each other, causing a small space to open at the equinoxes. This particular crack stayed open for 14 hours straight, something that's never happened before. If you're wondering if otherworldly beings may have slipped through this crack into our world, you can rest easy. No one entered. And besides, the Earth's magnetic field is not a protective barrier from other dimensions or worldly beings. Rather, this barrier protects the Earth from the powerful solar winds. You see, it's not only the ozone layer that curbs the effects of our blazing sun. The Earth's magnetic field also resists it. We don't give enough credit to Earth's magnetic field. It's a vital force that maintains the balance on our dear planet. Thanks to this field, our compasses point north, and animals can travel or migrate long distances and still find their way home successfully. Most important of all is the fact that the magnetic field safeguards our atmosphere from the harmful effects of solar winds. Solar winds are very powerful. If the magnetic field didn't curb these winds, they could rip our ozone layer apart. If you've ever seen auroras in the sky, they're caused by these winds. You see, auroras are beautiful from down here on Earth. Over there in space, they're dreadful, and you wouldn't want to stick your hand and grab those light rays like you must have thought. NASA experts have emphasized the danger of solar winds and how they can wreak havoc on satellites and cause citywide blackouts. This is why NASA has recently been actively monitoring and tracking the magnetic field. And guess what? They've noticed that the magnetic intensity has weakened significantly. And most of all, there is a significant error in the area spanning South America and Southwest Africa. Scientists have called this the South Atlantic anomaly. It's not clear whether these weakened spots are a direct result of the activation of the superbeam collider, but the incident with the broken magnetic field line has led many to believe so. Nonetheless, these weakened zones spell serious trouble for us. Researchers are most concerned about the numerous satellites and spacecraft in orbit. The increased exposure to the solar flare will be felt more by these crafts than by humans. Some of the most vital communication systems today are orbited in space. Telephone, radio, television, and even the internet use satellite communications. As more high-energy solar-charged particles continue to get to these satellites, they may malfunction or have other forms of technical glitches. Even worse, the sun is on a rampage these days as its flares are increasing, producing more powerful bursts of energy. Our sun doesn't just give off heat or light and radiation. There's also something called coronal mass ejections, or CMEs, which are massive eruptions on the sun's surface that arise due to instabilities in the sun's magnetic field. CMEs can be so powerful that they can cause nationwide blackouts and disrupt communication systems in seconds. Usually when these CMEs are released in excess amounts, they're referred to as solar storms. These storms carry electrical charges and heat, moving rapidly toward the Earth. Elon Musk lost 40 of his SpaceX satellites in one of such storms in early 2022. If you've ever seen a northern light, it occurred because of a solar storm. When these things happen, they paint the skies with a breathtaking display of colorful lights. However, as dazzling as they seem, these solar storms are great potential for havoc. Potential threats. NASA has announced that two massive flare eruptions are hurtling toward Earth at nearly 2 million miles per hour. If this results in a storm, we could experience radio navigation frequency disruptions, satellite malfunction, and even global internet disorders, resulting in losses as high as trillions of dollars. Of course, all this is just speculation, but it may not be far from the truth. One of the most catastrophic effects of solar storms was the Quebec event in 1989. Extreme solar storms knocked out power in various parts of Quebec. The Carrington event of 1859 was another terrible one and was the worst solar storm in history. It caused sparking and fires in many areas and also resulted in the damage of telegraph systems worldwide. But as destructive as it was, this event lit the night sky with beautiful bright lights that outshone the moon. That's the thing with solar storms. While they do devastating damage, they also cause astonishing sky decorations. Given the recent turn of events, we could now find ourselves at the mercy of such a storm again. Scientists still have a long way to go in understanding the mysteries of the Sun and the Earth's magnetic field. There's a high chance that the use of the Large Hadron Collider may have caused the recent flaws in the Earth's magnetic field system. CERN broke our magnetic field, opening a pathway for solar winds to invade the Earth. Some skeptical folks have even developed the theory that CERN may have opened up a portal to another dimension and is simply keeping it away from the public. Could this be true? Let us know what you think in the comment section. As far back as 2008, when the LHC first launched, some onlookers believed that it would cause the end of the world. There's just no way you can bring together so many magnets without any consequences. After all, the magnetic power of the Large Hadron Collider far exceeds that of the Earth. Maybe this is just the beginning of the damage the LHC will do. Some theories even suggest this super collider would one day draw an asteroid from space that would come to destroy Earth. We don't know that for sure. For now, all we know is that all scientific hands have to be on deck for us to neutralize the risks associated with the incoming solar storms. Otherwise, it could be a truly dark day for humanity if, for instance, the internet gets to shut down for a whole day. Whatever the case may be, it's all up to CERN and other world-leading tech and research organizations to come up with viable solutions. That's all for this video. Join us next time for another exciting episode. If you want to watch another video, simply click on any of the thumbnails showing now on your screen.